Okay, this is topic 10-2, rhombi and kites. So we're going to still be investigating properties of the quadrilaterals, and today we're going to look at rhombi and kites. So first, let's refresh our memory real quick from yesterday that these are the 5 properties of parallelograms, and it will apply to all the parallelograms. So a rectangle and a rhombus and a square are all parallelograms. So you should have these properties checked off on your chart for all 4 of those parallelograms. Okay, and then we're going to just look at the additional ones for each type. So both pairs of opposite sides parallel, both pairs of opposite angles sides are congruent, both pairs of opposite angles are congruent, both the diagonals bisect each other, and any 2 adjacent angles are supplementary. Okay, and here's our flow chart. So we are looking at today, we're going to look at the rhombus and the kites. And we'll see the difference between these. Okay, so let's look at rhombus ABCD that's graphed on the grid here. So thinking about the definition of a rhombus, remember, look at your fact sheet, but a rhombus is a parallelogram that has 4 congruent sides. So if AD is 3.4 centimeters, then the length of DC should also be 3.4 centimeters because all 4 sides are congruent by definition. Okay. Then if the measure of angle, or ask for the measure of angle AEB, which is this angle right here. Now, that looks like a right angle to me, but how are we going to check and see if it is? Let's look at the slope of the 2 diagonals and see if they are perpendicular. Okay, so the slope of DB, if you count and do rise over run, from D to B, we go down 2 and to the right 4, and that would be negative 1/2. And the slope of AC, if we look at that one, you would count up and over. It looks like up 12 and to the right 6. So that would be a slope of 2. So negative 1/2 and 2 are those opposite reciprocals. Yes, they are. So if they're opposite reciprocals, then that means they are perpendicular. Therefore, angle AEB is 90 degrees. And then angle CEB, which is right next to it because they're a linear pair, would also be 90 degrees. So in this case, then, this shows me that in a rhombus, the diagonals are perpendicular. Okay? All right, then it says if the measure of angle DAC is 20 degrees, so DAC is this side right here is 20, then what's the measure of angle BAC? If you remember from yesterday when we looked at the square, it should be 20 because the diagonal should bisect that angle. But let's look a little bit closer as to why. So if you look at this triangle, ABE, and you look at this triangle, AED, what you'll see is we know that these 2 sides are congruent by definition. These are right angles because the diagonals are perpendicular, and because it's a parallelogram, we know that the diagonals bisect each other. So therefore, in this case by hypotenuse leg, the 2 triangles are congruent, and by CPC-TC, all the parts are congruent, so those 2 angles would be the same measure. So that would be 20 degrees. Then, if the length of AE is 3.2 centimeters, that's this, then what's the length of CE? Like we said, it's a parallelogram, so the diagonals bisect each other, so that should be 3.2 centimeters as well. And then last, if angle DAB is 37 degrees, so DAB is this entire angle, then the measure of angle BCD, which is opposite corner, that should also be 37 degrees because it is a parallelogram. Opposite angles are congruent. Okay, so that's using congruent triangles, our definitions on our fact sheet, and prior knowledge to help us figure out the different measurements. Okay, so let's switch to the kite. So look at this kite, ABCD. Let's answer these questions using some of the same techniques. So look at the slope of segment AC. Segment AC is a horizontal line, so its slope is 0. Look at segment BD. That is a vertical line, so its slope is undefined. Vertical and horizontal lines are perpendicular. That means in this case, for kites, the diagonals also are perpendicular. Now, if AB is 4.5 centimeters, so here's AB, then the length of DA should also be 4.5 centimeters by definition. The definition of a kite is a trapezium with two distinct adjacent congruent sides. So those would be the two sides that are congruent. Well, let's take a look real quick at these two triangles. So triangle ADC, and let's compare that to triangle ABC. These two triangles are congruent because they share this side. It's congruent to itself by reflexive property. We know that the distinct adjacent sides are congruent. And these are congruent. So therefore, by side, 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 those two triangles are congruent. And by CPCTC, all the other parts would be congruent as well. So if ADC is 85 degrees, then the measure of angle ABC should also be 85 degrees because those are congruent triangles. And then if the measure of angle DAC is 60 degrees, so DAC is this one, then the measure of angle BAC would also be 60 degrees because they are congruent. All right. And then last we have, what's the length of segment DE? So let's erase this so I can see everything. So we should be able to just count. So segment DE is 8, right? And look, segment BE is also 8. Segment DB is 16. The length of AC is 15. Therefore, the diagonals are not congruent. From that, we should see the diagonals are not congruent. And then AE is 5 and EC is 10. So one diagonal is getting bisected, but not the other one. So it'll have one diagonal that gets bisected. Okay, and that would be the properties of a kite. So a rhombus is a parallelogram. It'll have those basic 5 properties, but a kite is a little different. It will not have the properties of a parallelogram.